Trapezoids, thank you.
Did we do an exploration on trapezoids? I don't remember. I don't think so.
What's an exploration?
Like that purple sheet where we learned about rectangles and squares.
Yeah, we did.
On trapezoids? I don't think we did. Oh, okay. Okay, trapezoids. You've all heard of trapezoid before, right? Yes.
Yeah, it looks like a triangle, but it's not.
Looks like a what?
Triangle, but it's not.
A triangle?
But it's not.
Like a triangle square thing.
Yeah.
Oh,
Cut the
right.
top of a rectangle. Cut one of the angles off the
Anywho, what do I know about these opposite sides of a trapezoid?
Parallel.
They're parallel, okay? So trapezoids are different from all the other shapes we've talked about so far in that they only have one pair of parallel sides, okay? Parallelograms, squares, rectangles, rhombi all have both pairs parallel. This one only has one pair. Okay? The other thing when we talk about trapezoids is our consecutive non-base angles are supplementary. We're used to our opposite angles being supplementary. These are consecutive non-base angles are supplementary. What that means, like these are our base angles, okay? So we want non-base angles. That means these are supplementary and these are supplementary, okay? In parallelograms and the other ones, it worked that you could go both the green way and this way. The blue way doesn't work anymore, okay? Just the green way. Just the up down.
I need
Okay.
colors.
Yeah, that's how I do.
Tango, use your restroom real quick.
No.
Please.
I got orange, brown, red, peach, yellow. I'll just do red.
That's okay.
Tango, use the restroom.
Oh, yeah, you can't get
Yeah.
What?
I think we told them.
Okay. So pretty much you're talking about the angles that aren't on the same parallel line. Okay? When we talk about isosceles trapezoid, you guys remember isosceles triangles? What does isosceles mean?
Two
Two sides are the same. Okay? So when we have isosceles trapezoids, our two legs are the same. Okay? Legs being the ones that are not parallel. Obviously my two sides that are blue are going to run into each other, so they're not parallel. Okay? So we're going to fill this in right now. Non-parallel sides or legs are the same. They are congruent. Okay, from above, we still have the one pair of parallel sides. Those are our bases. So this is the base. This is the base. Our left and right we call legs. Bases are parallel, legs are not. In an isosceles trapezoid, the legs are congruent. Okay? Our diagonals, the things that cut through, in an isosceles trapezoid only, they are congruent. Okay, that reminds us of what? Rectangles and squares.
Yep.
Both of those diagonals are congruent. Also a little bit different. Our opposite angles, instead of being congruent, they are supplementary. Think in every other shape they were congruent. Here our opposite angles are supplementary. And that's because our base angles are the same. They're congruent. Okay? What I mean by base angles are angles that touch the same base. Okay? So like our bottom angles touch this base. So these are base angles. They are the same. And these angles up here are the same as each other. Now they're not the same as the other pair of base angles, but they're the same as each other. Okay? Does that make sense? Okay, and then what it means by opposite angles, these two angles are supplementary. Okay? Since they are the same, it also means that we can go this way still, and those are all supplementary. Okay? So when we're talking about base angles, there are only two angles. The rest are the same.
Jeez, I hate trapezoids.
They're not that bad.
We just gotta practice with them.
Okay, the other thing we have is a thing called a mid-segment. Okay? I believe we talked about mid-segments of triangles. The mid-segment is the midpoint of the two legs. Okay, and then since we have all of our info in the same place, we're gonna put the formula to find our mid-segment here. It's also in our notes, but I just want to put it here because we got everything else here, okay? We use this formula, mid-segment is 1/2 times base plus base. So we add our bases together and take half of it, and that is the length of our mid-segment. And we'll talk about that more in the actual notes part, but I just want to put it there so we have all our info in one place. Okay. I know it looks like a lot, but we'll get some practice in, okay? Are we good on the properties? Okay. Alright, down to the examples of our trapezoids. Number 9, I have a trapezoid. It's not necessarily isosceles, okay, just a regular trapezoid. I need to find the missing angle, okay? Well, here's angle A. What do I know if I look at my top non-isosceles trapezoids? What do I know about my angles?
They make
They add up to
180.
180.
They add 180. Which ones? So it says non-base. So would that be the 76 or the 143?
76.
Good, the 76. So to find angle A, we take 180 minus 76, and how much do I get?
104.
104. Perfect.
The other one's 37.
Okay, chill. Okay, also looking for angle C. And I know that it is supplementary as it's 180 to which one? 76 to 143, Ian?
37.
Which one
I
is
thought you
it
asked
supplementary
the
with?
Oh, D.
D. So I take 180 minus 143 and now get what, Ian?
37.
Thank you. Okay. Is that one good?
Yep.
Okay. 10. I think the rest are isosceles, so we're down at the isosceles properties. It says we gotta find angles. Let's find V first. How big is V if I have an isosceles triangle? Or a trapezoid? Holy. Yeah, it's the same as this base angle. They share this base, so these two red ones are the same. So angle V is 71. Are angle T and U the same or different? The same. How do I find them? Yeah. 180 minus 71. What do I get when I get 180 minus 71? 109 for both of them. Because they are base angles, which are the same. Okay. Is that one also good? Okay. 11. What do I know about my opposite angles in our isosceles trapezoid? They're congruent.
Supplementary.
They're supplementary. Okay, so they add up to 180. So I have 11x minus 16 plus 5x plus 4 equals 180. If I combine my x's, how much x do I have? 16x
Minus 12.
minus 12, good. Add my 12 over and we get 192. When I divide by 16, we get what?
Don't do it. I'm finding the answer.
Got it. 12. Do I need x but is X with my last spot? Is that the next last thing I need to find? No, I need to find angle P. Okay? Well, angle P, if we have an isosceles trapezoid, is the same as what angle? X. So what should I do with this X? Plug it in to S. Yeah, so 5 times 12 plus 4 gives me how much? 64. And that is our final answer. Since they're the same. Okay, questions there? Feel a little bit better about trapezoids? Okay, 12. Still isosceles. How big is OP? 11. My legs are the same in an isosceles trapezoid. Good. How about CO? 8. I know my diagonals have to be the same, so these two have to match. And what about, what else we got? NP. How big is NP?
16.
22?
16.
How do you 16, honey?
Oh, yeah, yeah. It's 14 plus 6.
8, and then this is 14. 8 plus 14 is 22. Okay. Questions on sides, angles, diagonals of trapezoids? Okay. Next we're going to talk about is the mid segment. Okay. If you, oh, we got both of these. These two aren't too bad. Okay. Mid segment is just the halfway point, halfway length between my two bases. Okay. So all I need to do, actually, let's do 14 first. How do I get from 19 to 22? Plus 3. So if it's halfway, if 19 is halfway between 22 and something, to go back this way, I need to subtract 3, and what do I get? 16. So HI, this length is 16. Always check, is 19 in the middle of 16 and 22? Yes. Okay, so on 13, what's in between 41 and 49?
45.
45. All you gotta do is
I thought
take,
you had to do that.
add, divide by 2. Can you raise it a little bit? We're almost up, I promise. Okay, questions on flip book examples. What's up?
Why do we have to add the numbers and divide by 2? Why can't we just look at it and figure it out?
Because the next examples you're gonna do involve x. That's just how we get 45. Like if you're bad at guessing what's in the middle, checking, that's how we find it.
Are we only doing 6, 6?
Okay, 6, 6 in your notes should look like this. Quick recap. Quadrilateral has exactly one pair of what kind of sides?
Sauce.
Parallel. Only one pair of parallel sides. I'm looking at this EFGH trapezoid. My bases are the two parallel sides. One of those sides, I would say, is FG. Oh, too short. And it's off. What's the other base? E what? EH. So my other side, that's a base, is
Where are you
EH.
getting it? Oh,
Using this diagram though.
okay.
These are my bases. What?
What is that? First part.
That says FG.
That's a 5 that's turned sideways.
Okay. What are the legs? One of them is FE. What is the other one? GH. Those are the legs. in a regular trapezoid, not congruent. In an isosceles trapezoid, they are congruent. And base angles that go together, one pair that go together, are angle E and angle H. What's another pair that go together? F and G. So these angles go together, and these angles go together. Those are our base angles. Okay, in an isosceles trapezoid, our legs are what? Congruent, the same, equal. A mid-segment joins the what of the legs? A midpoint, good. So, like, if I guesstimated, that would be our mid-segment. The mid-segment is parallel to our bases. Okay, so just like our bases are parallel, our mid-segment is also parallel to those bases. Okay. And the formula again, mid-segment is 1/2 times base plus base. Sometimes, like in a book or something, you might see base 1, base 2. Just don't add the same base and you'll be fine. I think the base 1 and base 2 are kind of, I don't know, redundant. But you can add them in there if you want. Okay, you ready for examples? What's my mid-segment if my bases are 7 and 11? 9. Halfway between 7 and 11 is 9. If my mid-segment is 14, one of my bases is 24, how can I figure out what my other base is? 4. How'd you get that? Yeah, plus 10 here, minus 10 up top. Okay. Questions on those two? Okay, now here's really where I would use the formula when it involves x's. Okay, so formula, mid-segment equals 1/2 times the bases added together. My mid-segment here is represented by what expression? 4x plus 1. So we have 4x plus 1 equals 1/2 times, my bases are 1 what? 6. Yep. And 10. Good. So I have 6x minus 2 plus 10. Okay. Questions on where that stuff came from? Okay. I would simplify the parentheses first, so let's copy down everything up to the parentheses. What is minus 2 plus 10? 8. Now I need to distribute my half. Okay, so I'm going to leave my 4x plus 1. Half times 6 is 3, so I got 3x, half 8. 4 minus 3x, so x plus 1 equals 4. X is how big? 3. And that is all we need. Okay, you do the next example. Okay, did we all set it up this way? What did you do, Jake?
Put the 2x in bottom 3x.
So our mid segment always goes out by itself.
Oh,
Okay, and then the bases go together. Okay, who got an X value for this one?
4.
Nine.
Oh, 9.
9?
Nine.
Let's do this one. Okay, so 3x minus 6 equals a half. 2x plus 24 when we add. Distribute my half. I get x plus 12. Subtract my x.
18 to
2x equals 18. X equals 9.
That's, I on accident wrote 8, like forgot the 1.
Oh, gotcha.
Yeah.
That's
I
okay.
got 21.
You got 21 votes, and then why did you get 21?
I did 2 first. The 2x.
Oh, so you did like Jake with 2x on here? Yeah, mid segment goes up there. That's okay, learning. Okay, mid segment trapezoid. Here's my trapezoid. Mid segment is 16. Levi, will you give me one pair of possible lengths for the bases?
2x plus 5.
Not x's, just numbers. If the middle's 16, this could be what, and this could be what?
The bottom one can be 24, and the top can be 8.
So 8 and 24. Is 16 in the middle of those?
Yep.
Yeah.
What else works? Riley, come up with one.
15 and 8 or 15 and 17.
Yeah, 15 and 17. Well, Ian, you look eager. You got one?
14 and 18.
14 and 18. 16 just has to be in the middle of them.
0 and 32.
That's easy.
That's
Yeah,
easy.
Levi, what did you try to say?
Levi is a champ. Okay, questions on